Thank you. Yeah, welcome. Great to be here again. Last year I talked about Google Tango, and last year Arcore was released just 3 days before the actual talk was. So I had to spend a whole weekend getting up with all the reading all the documentation and preparing the slides. This year there's a similar situation. I will let you know why, or after this talk you will know what I'm talking about. So first of all, let's set some expectations straight, because it's always a level of detail, and I know this is a developer conference, so you guys are really interested in the technical details, but in my experience, it's better to show you the points where you are able to look things up yourself, because the actual details, you will have to read the documentation, you will have to do the code labs, and I don't think it's such a good idea to show too much code, because either it's so simple that you wouldn't have to tell us tell the information or pass the information on as actual code, or it's so complicated that you cannot comprehend it in a speed that's a good idea for a talk. So I will do no product presentation, I will do no code lab either, and there are a lot of excellent talks on Arcore and a lot of excellent documentation. If you really want to write an app, I will point you to the places where you can look everything up that you need to build an app. So it's rather about collecting the information from different resources about AR, and more specifically Arcore, and all the tools that you actually can make use of to build a high-quality AR app. So also, I will do a quick recap of the current state of AR devices in general, and in short, outlook what AR might become in the future, because AR is, in my opinion, more than just some cool gimmick to show, to augment like products or show cards on top of postcards. But that's the use case that you actually see most of the time, but in my opinion there's more to it, and I will try to explain why. Okay, this is the one slide that has the most characters in the whole talk. Please forgive me this, but we have to get a common understanding what augmented reality is and what it's all about. So generally, the key points that you can take from those definitions is that it's real-time. It combines many different senses, so vision, sound, maybe haptics, and it's in real time, as I already said, it's interactive. So even though the football game is a great example, there are a lot of effects that are kind of AR, but they're not in real time and they're not interactive, and that's the difference. And it's registered in 3D. So these are two definitions. One is from Wikipedia, one is from Ronald Azuma, who did an excellent survey of augmented reality in 1997. And this is the next thing I want to point out. In this talk, he also did a great talk where the types of AR systems can be separated, or where he grouped the AR systems into different display types. So one thing, like for example, the HoloLens is an optical see-through system. So in contrast to a video see-through system, which Arcore, how Arcore works on the smartphone. So you have a camera, you have a display, and the augmentations are on the display. So in the HoloLens, it's done in an optical system. These two differences might be technical, but in fact, there is another form of AR that is thinkable, and there are prototypes for that. It's projective AR. So you don't even need a device that you wear, or no glasses, no smartphone. It's just projected in your surroundings. And this is a concept that's not a hype. It has been around since the first tool that man has created. You need a light source, then you can cast shadows, and there are techniques to tell stories with shadows and to transport information with that. So it's an old topic. It's nothing just a hype. The basics of that are real, go way deeper. If you try to find the first AR device as such, as technology, you could go back to mechanical solutions like the kaleidoscope or the pocket watch with a music box inside. So if you take the term AR a bit more general, these are augmenting the world with more information or with optical effects. The next step would be like the cinematograph or the tinfoil phonograph. So the ways to project images or to record and replay sound are part of this whole evolution that took us where we are now. If we move on a bit more quickly, these are the first head-mounted displays or headphones. So this is from 1880s, and this box approximately weighs 10 pounds. So this is the way the first telephone connectors were working. So they had this loudspeaker on their shoulder in a harness. So, and the first head-mounted display, which is only related to AR, I know, but it's an interesting fact to know, was called the Sword of Damocles because of its massive dimensions and weight. So you can see it here. The first device that really comes close to what AR is all about was developed by Rosenberg in 1992 for the US Air Force. And this was more like an experiment, so it wasn't an actual device. And there's a setup with a robotic arm that you can see here. And you have a board where you had to complete specific actions. And the experiment was, does this optical guidance that it's augmented upon the scene help the people to do the task more efficiently and more precisely? And this was the first mention of AR as such. And what you see here is the first working AR device that Ronald Azuma built for his dissertation, or at least it's referenced in the dissertation video. And what you can see here, it's in 3D, and it's basically these lines are aligned with the object, the real object. Okay, we will come to mobile AR, I promise. Just a quick recap of the current state of the art in 2018. There are AR glasses, but those are more like, they're too expensive for consumers and they're not really socially acceptable and still prototypes. So there's a lot of technical things to tackle and technical things that have problems that have to be solved. Okay, what in the future? There's this. There are references in movies like Altered Carbon, where you have a contact lens that actually augments everything, and there are experiments going on to make use of contact lenses, but not as AR devices at the moment. So that what you see here is Google's patent on a glucose meter. So, and these are actually prototypes that have an optical display like 16 times 16 LEDs, and there's an experiment that by Parvitz that tried how long these could be worn. So as such, mobile devices are not the ideal interface for creating AR experiences because it's clumsy. You have a very restricted field of view. You do not have your hands free. It gets strenuous after some time. So if you have an experience that takes on for maybe like half an hour, you're tired after that. And you need space. You cannot really freely move around, and it's not ideal. Still, there are enough reasons to actually still do it, still create augmented reality experiences. Why? Because we have an ecosystem. People are used to pay money for digital content on Google Play or all the mobile OSs, whatever. And you actually, today, you can reach billions of users when you create an AR app. So, another thing is, why is smartphone ideal as an intermediate technology to create our AR experiences? Because basically all the basic parts are there. So you have a display, you have a camera, you have enough computing power, you have sensors like IMUs, the inertial measurement unit, you have a touch screen, and you have localization hardware, which might be interesting for use cases where it's not like table-sized or room-sized experiences, but you can move around in the world. I just wanted to point you to a wrap-up paper about the history of mobile augmented reality, because this actually goes way back. It's not something that has come up last year. And the key points in this slide is that it hasn't been a long time since the first phone that had GPS built-in was released, and the first camera phone even. It's like 18 years ago, the first phone with a camera was released. And this is, so if you're interested in the history, just look that up. I will hand out the slides later on. Okay, if we look at the software side of things, there have been a lot of solutions around. I don't want to go into detail on each one of them, but we are going to focus on Arcore. By the way, this isn't even complete. Amazon and Facebook have their own solutions too. Okay, so a quick intro. Who of you has heard of Arcore? Okay, many of you. Who has actually tried it or built a sample project? Okay. It's available for a couple of platforms. It's not only native Java or Kotlin development. You can use it with the NDK as well. You can use it in Unity, in Unreal, and even for the web. And with the new features that were announced at Google I/O, there is even a way to use it cross-platform with iOS. So you can have cross-platform experiences, but I'll tell you more about that later. So what's new? As I said, it's a similar situation like last time. This time there were 2 new features announced. So we heard a talk about Scene Forum yesterday. So this is one feature that's really important and developers have been waiting for. There's 2 new features which are called Augmented Images and Cloud Anchors, which are just going to quickly discuss, just you know what it's all about, and have some knowledge how you could create an app with those. For the details, please look it up. Let's start. So these 2 features, this is the one thing, but tooling has really improved since I/O. I mean, there were alone 7 talks on Google I/O this year about AR that introduced or were in the broad sense relevant for Arcore. And apart from that, I collected some tooling that you really should know if you want to create an AR app. One is Scene Forum that we already talked about. You have Android Studio integration for Scene Forum that you see here. And you actually can edit things too. So what I did here, this spaceship wasn't metallic before. I just switched it to be metallic and it updated like in a couple of seconds. And you actually can work with that. And this is something that we didn't have for Tango devices or for Arcore so far. Just a quick wrap up where I will talk about these in detail. So there's JAPID, which is for debugging, which might be interesting for you even if you are not doing an AR app, but a 3D OpenGL app. And of course, there's audio, because ideally AR is multisensorial, so it's not only about vision, it's about sound too. And there's a toolkit called Resonance Audio that is basically was intended for the Daydream apps or cardboard apps that you can use with Arcore 2. And last thing is Poly, which is a place where you can get your 3D models and that you are able to import into scene form. Okay, so as I said, as I already told you, there were 7 talks that were relevant to AR. I just wanted to list them as a short thing that might be useful for everybody who looks at the slides after this talk. So basically, you can find them in the Google I/O playlist as well. But there are a lot of best practices and a lot of information that you would have to find out the hard way if you just try it out yourselves. Because, I mean, Google can spend the resources to iterate in design sprints or to evaluate the user experience. And this is these are lessons that you don't have to learn yourself, but you can make use of the best practices. Okay, let's quickly walk through the feature set of Arcore. The basic thing is, if you want to present something in AR, that means it blends into the real environment optically. The hardest, or one of the key problems, is that you have to track the device's motion in space. And this happens not only with the sensors. The IMU is, of course, a key point or a key technology that you need for that, but it has its problems too. So sensors are not ideal. So they produce error, and if you have high frame rates, like 100 hertz, then these errors add up, and this is a concept called drift. So this happens if you look in your try out an AR app and things start to float away. This is something that can be corrected for by the user's environment. As you see here, this is taken from the Google documentation. So there are key points here that help to stabilize against this sensor drift. So otherwise, the device wouldn't know, okay, am I still moving? The sensor tells me, yes, I'm moving, but the image doesn't change, so it can be corrected. So just to get some terms right, when I'm talking about poses or a pose, or the documentation reference poses, this is meant. So it's the device position in space, which is 3 transitional components and 3 rotational. So this, as such, makes up a pose in Arcore. So if you look at the key feature that we were talking about is motion tracking, and this is basically from the Tango. It's an app that was shipped with Tango devices, but you can see what it's about and what the precision is. Just to give you an impression, if you use other technology like beacons or Wi-Fi to track position, it's not as, I mean, this circle has about, I don't know, 4 meters. So it's basically standing up from the table and just walking around the table and sitting down. That's what you see. But as you've seen, it's really smooth. So you have 100 hertz. And if you use beacons, you get updates twice a second. And these position varies between how much effort you're putting into stabilization between maybe 0.5 meter or 2 meters. So this is something completely different, right? The second feature is environment understanding. So from the movement or the differences in the camera image, Arcore is able to detect surfaces in the environment. So, and if you have a look into how it actually looks in the apps, these dots, they indicate that a surface has been detected. And another term that might be interesting is anchor. Anchor is a combination of a pose and the actual point cloud or feature set of features that connects it to the real world. Yeah. So this plane, you can anchor it to the real position, and that's why you that's the concept of anchors. In order to so that the augmentations look realistic, you cannot just paint them as is, but they have to be lit in the same way that the scene is lit. Because if you're in a very bright space, then your augmentations won't look right. But even worse, when the lighting is pretty low, things will just seem to glow from inside if they're not correctly lit. And this just breaks the immersion. You even can react to changes in the lighting. Maybe you have seen the example with the Wizard of Oz, the lion that starts to get afraid when you turn off the light. So this is basically, you can use lighting as a trigger as well. So a new feature that was introduced is called Augmented Images, and this is something that's actually been around for quite a while. So if you used any of Metaio, Wikitude, Vuforia, or any of these AR platforms, this is something that they were able to do like years ago. And this feature has been put into Arcore. So basically what it does is it recognizes an image and then uses this as a reference point so you can place your augmentations. And there are a couple of use cases. So this is like the basic thing. You have a postcard and you show a model of a product on it. Yeah? Or you have a product box, and when you scan it with your phone, the model, the actual toy that's in there, starts flying around, whatever. Huh? The second thing, which is from my perspective more interesting, is called cloud anchors. And I just explained to you what anchors mean. Anchor help to connect the real environment with the virtual environment, and they can be shared across devices. This is something that's new, and this is something that's really important because you don't want, because you now are able to create multi-user experiences that work across devices and even across Android and iOS. So this basically, technically, it works in a way that when you have detected a plane or the environment with device A, you can host it and upload a small portion of the features and the position to the Google Cloud. And then on the second device that wants to join the experience, you can call resolve, and you get an ID that you have to pass around by your own servers or by your own backend infrastructure. And then when the client device or the second device B resolves that ID and then can join in the same experience. Okay, I talked about tools. As I said, the tooling has dramatically improved. That's mostly to the fact that you have SceneForm and that you have Android emulator integration. So you don't need an Arcore-enabled device, because you saw that the device list is getting longer and longer, but still you might not have one of those. So if you want to develop, you can also do this on the emulator now. So this is how it looks. So it's like a first-person game. You can just move around. This is like the Android Studio plugin for SceneForm that I already told you about. So SceneForm is like a 3D engine. And this is something that has been missing for a long time. We started developing for AR when it's with Tango devices, and we had to rely on some open source solutions like Rajavali, which were badly maintained and buggy. And this really, the other possibility would have been to really write OpenGL code, which is really technical and doesn't help if you want to create. So it's useful to have a different level of abstraction for that. So the cool thing about SceneForm is it helps in a way that you don't have to do the hard math. Yeah? So 3D math might be or can become very tricky, especially if you have different coordinate systems that you have to convert from and to. And especially if you think of a solar system, the sun is in the middle, and you have a planet and you have a moon of the planet. The task to calculate the rotation path of the moon can get tricky, and this is something that that SceneForm can help you with. So you just can calculate the animation in regard to each other. But the more from my point, even more interesting part is that you can actually use Android standard UI elements and put them in a 3D world. So these are layout files like you know them from Android development, yeah. And you can just place them somewhere. And this is one of the reasons why I think this is very useful, yeah. So you can, with the tools you already know, create new experiences, and you will have new problems that you haven't known before because it's volumetric design. So things can be in front of each other, and things can be placed in a 3D place. Okay, another thing that you yesterday mentioned was poly, and that's another thing that was really tedious, like importing 3D objects into an engine or something like Rajavali, or reading them for OpenGL can be tedious and error-prone, and this is something that has been improved, so you can import 3D objects into SceneForm, and it does all the heavy lifting. And with Poly, you have a website where you can actually search for publicly available models and just download them and in a couple of minutes import them to your project. Because not every Android developer is automatically a 3D artist, right? Okay, I said it's multi-sensorial. So game developers have long noticed that to create a feel of immersion, audio is even as important as the visual part of your app or your game. So if you use resonance audio, you can place, of course, the basic thing is that you can place sound sources somewhere in the environment, and they actually, if you listen to it, it really sounds as if they're if they move correctly. But there are more advanced concepts, like you have occlusion. So what is if the sound source is behind a tree? It will sound different, yeah? Or not sound sources are directed. So if you think of a trumpet, the main sound is coming out of the trumpet, and if you listen to it from the side, it sounds different. Just as an example. Okay, one thing that for you as a developer is really important is like debugging, because if you're not the total OpenGL mastermind, and you already know what's wrong about the calls that you're making, or this is something that you definitely have to be able to inspect. And this is something that you can use Japit for. So with Japit, you can really look into every detail of the draw steps, and look at all the objects and the materials and the textures, and you can step through this and see what's actually happening. This helps to identify problems like overdraw. So another thing that's changed is, as I already mentioned, there were so many talks with a lot of information that is important not only for you as developers, but for the UX part of the team as well. So you cannot just apply all the knowledge that you have built up by creating 2D apps for an AR app. So one thing is, don't litter the screen with buttons, because this will take up so much parts of the screen that you actually cannot really see the AR experience anymore. Yeah. So things that should be on the surface of the screen are only really, really primary actions. Now, this is just one takeaway. In fact, there are separate talks about this topic, and there were something called the pillars for AR design, which include the user's environment. You can use multiple surfaces. You have to think of the user's movement, the user's scale, so users can be big, can be small. About how do you initialize the user into AR? How do you interact with objects? And not last but not least, how do you the volumetric interface design? Huh? Okay, if you create an AR app, the technical part and the UX is not everything you have to think about, but you need to think about what is the actual product value of my app. So this is something that you actually can buy, there's one quote that I want to make. It's that your app has to create a meaningful connection between the real and the virtual world, which is the quote is by Ronald Azuma that I quoted earlier as well. But this is important. So if you just use AR as a gimmick, the effect will wear off pretty soon. People will just download it, try it once, and deinstall it. So you have to think about what is actually helping the user, and how do I connect the real world to the virtual world? Okay, there are different types of AR applications that I earlier mentioned. Like you have table-sized experiences where you put maybe a toy or a virtual environment on the table or objects, or then there are room scale experiences like a game where, where I can augment virtual things into a room scale environment. Or there's something like the often quoted Pokemon Go, where the augmentations are everywhere, can be everywhere on the planet. If you really want to connect the virtual world to the real world, localization is one key thing that you have to take care about. So, and GPS is one thing. You have like 5 meters precision, which is not enough for AR, because depending on where you are, 5 meters make the difference whether you are inside a building or you're on the street or beside the street. So this has real impact. That's why an omnipresent positioning system with high precision and high frame rate is really needed in order to make world-scale AR apps feasible. Another thing that Google just started creating with these multi-device experiences is called the AR Cloud. And there are separate talks on that as well that I can, that are really interesting. So, and this is basically, you need a virtual representation of the real world when you want to put augmentations everywhere across the globe. And you need an instant ubiquitous localizer, that's what I just mentioned, and you need some kind of scalable, shareable point cloud. And the question is, how is that created? There are different approaches to that, but we'll see what actually works. And you need real-time multi-user interaction. And this is something that's just a new feature that has come out, so we can start to really cooperate in these augmented worlds and work together on digital objects. And this is not only for games interesting. It could be, you could work on as an architect, work together on a 3D object that's projected on your table, and you could share this experience with coworkers and contribute to the same object. Okay, if you think, I mean, this slide looks a bit like you take all the hype topics of the last 2 years and put them on one slide. I know, sorry for that, but it's about the context that you have to think about. If you have a real good AR device, and I'm not talking about smartphones, I'm not talking about, maybe not talking about glasses, what might be the next step, that you can use, and that's socially acceptable and doesn't make you look like the king of nerds, then all these areas could work together to create like a paradigm shift to a new kind of user interface. Yeah? So if you think computer vision, things like the Google Lens, object recognition, face recognition, all these things put together really make up new worlds of possibilities. And I think the last thing I'm going to show you is one research paper, or it's a site for computer vision and pattern recognition. So this is a research topic at the moment in 2017, and this is what you can do. You can, if you take an image, you can automatically analyze things like there's the face of a horse, and there's a mountain behind a horse, and there's a man wearing a shirt, riding a horse. So, and you can extract these kind of graphs of information just from images. And if you put things together, you might have AR glasses that really understand the user context and are able to create experiences that really fit to what the user has to know. So you can show the information that the user actually in his context requires at the place where it's actually needed, and not on a device, but in the real world. One great example that is cited in one of the Google I/O talks is you just open your phone, and if you say you want to learn French, you just do object recognition on everything that's around you. So you can, and you detect the object and show the French translation at the object. So, and then this is something that's actually a prototype that's actually working. And if you start to think like that, a whole new world of possibility evolves. And yeah, I think this is far more than just putting a product on the table. So that's what I was referring to. If you really put this in context and think about all the connections to the different types of area, or the different areas where we're actually making huge progress, this really gets, well, it gets clear that it's an exciting time to do an AR application, and you can really think of really new things that haven't been there before. Thanks for listening.
So we still have a couple of minutes. If some of you ask questions, there are, as always, the microphone at the side of the stage, and I can come with my microphone in the front.
Yeah, just one question. The image recognition, is this also only for the supported devices? Because I would think that the calibration isn't that necessary for this kind of stuff, or do you have anything?
What do you mean by image recognition? You mean augmented images?
No, not augmented images, but the postcard where you put a line on it or something.
Yeah, that's augmented images. So you you can create a database up to 1,000 images, and track up to 20 of those in real time, and then use them as a reference frame for putting objects. And this works on devices that support Arcore, yeah.
So not all devices, only the supported also, because...
Yeah, but actually the list is really growing, so yeah. I can go back to that slide if you're interested in the details. You can look it up as well. But, no, there was. So this is basically a lot. I mean, this is, I think, the last time I do an Arcore talk that I'll really put up all the devices, because nobody actually reads that. And of course, I added the Apple devices because now you can interact with ARKit. But I mean, many Samsung phones are there, and they make a big market share. Huawei phones are there, and this, okay, it will take time. Of course, legacy users with legacy phones might not be able to use it. That's true. So you still have a limited user target audience, but this will evolve over time too.
Okay, thanks.
Can I ask about the devices which are not supported? What do you think? But why would some device not be supported if it's released this year? I mean, what kind of an issue of hardware? Because there is not a single tablet on this list, only phones. Yeah. If you do something for business, you have tablets a lot. And
yeah, I mean, I think there are two reasons. One is performance. So that might be, if it's a new device, it might not be an issue. But there are kinds of devices that just are not supported because they cannot keep up the computing to actually calculate the positioning and detection. The second one is that you really have to have specific knowledge about the device the device configuration. So where is the IMU placed in respect to the camera? Yeah, because this influences the movement and the detection. So what's the focal the focal point of the camera? So what's the characteristics of the lenses that are in there? So this is why, for example, Apple has way better a head start, because they know every detail of the hardware that's in the devices. And this is something you have to calibrate those devices. Yeah, so there's a
Shouldn't be on the side of the maker.
Yes, yeah. So that's why I guess Google is just.
Why is Google doing that? I mean,
no, I don't think they do. They just partner up with device manufacturers, and of course they want you to buy the new devices. So I guess they will add this as a feature for the new ones. Apart from the performance issue, that might be a case too. So, but I actually I don't know. But these are two reasons why a device might not be supported.
thanks.
So we are out of time right now, but I think if you still have a question, you can still ask after the talk. And have a nice continuation. Enjoy the match if you like football, but don't forget to attend the last talk and enjoy have a nice continuation of the conference, and make a huge applause for Till again, because it's quite late and it's tiring and there's a game playing and he likes that.